There are two principles to understand before conducting an acid-base titration. The first is the neutralization reaction between aspirin and sodium bicarbonate. Aspirin, also known as ASA, is a carboxylic acid. Aspirin will react with sodium bicarbonate to form sodium aspirin salt, carbon dioxide, and water. Aspirin will act as a stronger acid and react with a weaker base, which is sodium bicarbonate. And this will form the sodium aspirin salt, which here is the stronger base. And the weaker acid formed in this reaction is carbon dioxide and water. Hence, from this equation, we get the ratio between sodium bicarbonate and aspirin, which is 1:1. The second principle is about acid-base indicator, also known as pH indicators. These are substances that changes color with pH. They are usually weak acids or bases, which when dissolved in water dissociate slightly to form ions. In this experiment, we use phenolphthalein. In this reaction or equilibrium, phenolphthalein acts as the acid, while its anion, which is negatively charged, is the conjugate base. At low pH, when the hydronium ion level is high, the equilibrium will shift to the left, and this results in the solution turning colorless. At high pH, or under basic conditions, the hydronium ion level will be low, and this is achieved after all the aspirin has been neutralized, and we are at the end point of titration. In this case, equilibrium will shift to the right, and in this case, the concentration of anions is enough for the pink color to be observed. Before, the solution is colorless because there is too little anions. Before, the solution is colorless because there are very little pink anions, and hence it appears colorless. For the calculation, we want to calculate the purity of aspirin in the 0.2 grams of aspirin powder. The average volume used of 0.006 molar sodium bicarbonate is 10.075 ml. The first step in our calculation is to find the mole of sodium bicarbonate. First, we convert the ml to liter, and we got 1.0075 times 10 to the power of negative 2 liters. And we found the mole of sodium bicarbonate, which is 6.045 10 to the power of negative 5 mole. We found the mole using the ratio of sodium bicarbonate and aspirin, which is 1:1. Hence, the mole of aspirin is 6.045 times 10 to the power of negative 5 mole. Next, to find the weight of aspirin in the sample, we had to find the molecular weight of aspirin, which we found to be 180 grams per mole. From this, 1 mole of aspirin is equal to 180 grams. Hence, 6.045 times 10 to the power of negative 5 mole of aspirin would be equal to 1.0881 times 10 to the power of negative 2 grams. And the last step, to find the purity of aspirin powder in percentage, we calculated the total weight of impure aspirin powder used. We used 200 milligrams, which is equal to 0.2 grams. Hence, the purity of aspirin powder, as calculated, is 5.44%, and that is the purity of aspirin powder found inside the 0.2 grams of aspirin sample.